Welcome to Lesson 3. Till now we have gone through the importance of data analytics and its importance to business. Also we have learned that the data has grown big in recent times and would continue to grow. In this lesson we would understand how this big data can be analyzed and processed for use. Grace Murray Hopper, the famous American computer scientist who developed the first compiler and conceptualized the idea of machine-independent programming language, gave a real nice example for this. She explained, historically ox were used to carry the load, but when the load increased, we didn't consider to grow the ox large, but instead we used several ox put together to pull the heavy load. The same idea is applied while analyzing big data. When this concept is applied to the computing world, it is termed as distributed computing, and this, as well, is the core concept to Hadoop. Let us see this problem in computing world. We had computing resource and data to process. As the data grew, we had an option to grow our computing capacity as well. So we did. The data grew at a large speed. This solution of upgrading computing device increased the expense as well because of three primary reasons. First, the hardware cost. Second, the licensed software cost. Third, high risk of failure. Further, it had an upper limit to the capacity of the data that can be processed. But the data is always increasing. In this case, Hadoop's distributed computing concept comes to save us. Instead of one powerful machine, the task was distributed among a cluster of machines. Advantages? First, low hardware costs as commodity hardware was used. The term commodity hardware is often used to refer to a node specification in Hadoop's cluster. It means commonly available hardware available with many vendors. Don't confuse it with cheap hardware or low-grade hardware. Second, licensed software is free. Third, reduced risk of single point of failure. In a cluster, if a node fails, the performance degrades, but does not halt, as it would in case of a single machine usage. Fourth, studies have shown that in certain situations that Hadoop's distributed cluster can process 10 times the data at 1/10 of processing time with 1/10 of price. Interesting, isn't it? On this slide, we would compare traditional database management system with the Hadoop MapReduce. I haven't described MapReduce yet, but I want you to think it as a framework that works in a distributed fashion on a cluster of machines. Don't worry, we'll look at MapReduce in details in the next section. So coming back to the comparison. This is in many ways similar to a comparison between a cool car and a train engine. A cool car is expensive but fast to carry a small number of people. Train, on the other side, would produce a higher throughput by carrying a lot of load. Each has its own benefits and so should be applied cleverly in accordance to the need of the situation. Let's look at this table. RDBMS is a good option with the data sizes in the range of gigabytes, while MapReduce would start to shine on its performance for the data sizes in the range of petabytes and upper. RDBMS offers both interactive and batch accessing options on the data, while MapReduce is only batch. Data access patterns in RDBMS is read and write many times, while in Hadoop file system we cannot edit a file. We would rather copy it to a local file system, delete the original in Hadoop file system, and copy it again with the modifications to be done. In RDBMS, the schema should be present at the time of loading the data itself, while in Hadoop, the schema binding is delayed till the time of processing. This is one of the major advantages of Hadoop. Let us understand this with an example. Let us consider that from a market research firm, we get data about the activities done on social media in relation to our bank. Let us say column 1 be the source, like Facebook, Twitter, column 2 be timestamp, and column 3 be comments. In the RDBMS version of the solution, we'll have to store it to a table for which the schema and other constraints has to be decided beforehand. In Hadoop, we just need to copy it to Hadoop file system, and at time of read, we can decide on the schema. Let's say we can combine the first two columns into one and consider C3 as column 2. Now if we do a sort on column 1, all the data would be sorted by the source and every row from the same source would be sorted by the timestamp. This gives us great flexibility in programming. Next, in RDBMS, we keep the data normalized, while in Hadoop, the data is not normalized. This facilitates in complex joins. Next, scaling. As the data increases, the processing time of relational database system increases exponentially, while in Hadoop it is linear. In this slide, we see an interesting analysis on seek time. Seek time is improving a lot slower than the transfer rate. Typically in 90s, the disk drive would be of 1 GB and transfer speed would be around 4.5 Mbps. Thus the time taken to read the whole drive would come out to be roughly 4 minutes. Nowadays, the typical scenario is 1 TB memory and transfer speed is 100 Mbps. Thus the time taken now to read the whole disk is close to 2.8 hours. Referring the aux and load example, it is like load has increased and so has the aux got stronger. But the increase in load is a lot more than the increase in aux strength. This gap can be closed by parallelism. Suppose the same 1 TB is distributed equally over a cluster of 50 nodes. The complete read time would reduce to 1 by 50th, that is 3.5 minutes. This is another advantage with Hadoop as it employs parallelism. One more advantage is that Hadoop maintains the replicas of the data, so failure of one node doesn't affect the integrity of the whole data. We would see in depth about how Hadoop maintains the replicas in a separate lesson.